All right, today we are beginning a new unit in math. Today we're starting our introduction to ratios. In this lesson, you're going to learn what ratios are and actually practice making a couple of ratios. So let's remember, before we begin ratios, that factors are important. The factors of 4 are 1, 2, and 4. When I say factors, I mean whole numbers I can multiply to make a product. The factors of 6 are 1, 2, 3, and 6. And that's because 1 times 6 is 6 and 2 times 3 is 6. Notice that 1, 2, 3, and 6 are all the whole numbers I can multiply in order to make 6. The common factors of 4 and 6 are 1 and 2. Those are numbers that are factors of 4 and factors of 6. That's why we call them common. The greatest common factor of 4 and 6 is 2. And that's because 2 is bigger than 1. Or, like we say in math terms, 2 is greater than 1. So now let's look at the factors of 16, 20, and 32. You can see them right there in example B in front of you. We're going to look for the common factors of 16, 20, and 32. Well, as I look, I notice that the number 1 is in every single line. 1 is a factor of 16, it's a factor of 20, it's a factor of 32. In fact, 1 is a factor of every number. So 1 is a common factor of 16, 20, and 32. 2 is also in every single line. Did you see that? Did you notice? 4 is also in every single line. So 1, 2, and 4 are common factors of 16, 20, and 32. Now, even though 8 is a factor of 16 and 32, it is not a factor of 20, so it can't be said to be a common factor of all three. And even though 16 is a factor of 16 and 32, once again, it's not a factor of 20. So the ones that are in common are only the ones that meet the requirements of every standard we've set up. Now, let's look for the greatest common factor between 1, 2, and 4. Well, that's easy. Which number is the biggest? You've got it, 4. So 4 is the greatest common factor of 16, 20, and 32. Now, let's keep going with our let's remember. Let's see. When we find the greatest common factor of 16 and 20, it's 4. We divide the numerator and denominator by 4 in order to simplify this into the simplest form. Now we're going back to remember fractions. In a moment, you're going to realize that there's a big connection between fractions and ratios. So, looking at my example there in the bottom of my screen, I'm trying to simplify 16 twentieths into a simpler fraction. And I'm going to do this by dividing both parts by 4. 16 divided by 4 is 4, and 20 divided by 4 is 5. Okay, so 4/5 is the simplest form of 16 twentieths. Now, I'm going to use ratios to compare two quantities. Before, we've used fractions to compare two quantities by creating a numerator and a denominator. We used to find a pie, select 3 pieces out of the total 5 pieces of a pie, and we would call that 3/5. We had one number to show what we selected, and we had another number to show the total number of pieces available. Now we're going to use a ratio to compare two quantities. I want us to start with the quantity of blue mugs versus the quantity of red mugs that Sam has. He's got 3 blue mugs and 2 red mugs. So we can write that ratio as 3 to 2. Notice how I'm saying the words 3 to 2. That TO2 can also be replaced by a colon, those 2 points, one on top of the other. So when we compare two quantities in terms of a ratio, we put the first term on the left and the second term on the right. So this would be 3 to 2. Let's try again. Let's write the numbers in the same order as the words. First, I'm going to compare triangles, which is on my left, to circles on my right. There are 4 triangles and 3 circles, so my ratio is 4 to 3. Now, if I change the order of the words, I have to change the order of the numbers as well. Let's compare circles to triangles. There are 3 circles and 4 triangles, so my ratio is 3 to 4. See? Now you try. What is the ratio of circles to triangles? And what about the ratio of triangles to circles? Let's see if you've got it. The ratio of circles to triangles is 4 to 3, and the ratio of triangles to circles is 3 to 4. In this next example, Manny bought 3 storybooks and 1 kite. Let's find the ratio of the number of storybooks to the number of kites. That would be 3 to 1. The ratio of the number of kites to the number of storybooks is 1 to 3. But be careful. 3 to 1 is not the same as 1 to 3. In fact, they are opposites, and we're going to learn that in ratios, the order matters. When we compare the number of boxes, because both boxes contains the same number of pens, okay? So in each box, we see that there's the same number of pens inside. So the ratio of the number of blue pens to the ratio of the number of pink pens is 1, 2, 3, 4, 5 blue to 2 pink. So we're going to call that 5 to 2. The ratio does not give the actual number of pens. It just shows us that for every 5 blue pens, we have 2 pink pens. Now let's do. You're going to write the ratios, the number of triangles to the number of circles. There are 2 triangles and 5 circles. Now you're going to write the ratio of the number of circles to the number of triangles. Really pay attention to the order of the words. The order of the numbers should match the order of the words. Next, we're going to write the ratio of the number of bottles of jam to the number of bottles of peanut butter. Now, I want you to notice that we don't need to count every single bottle of jam or every single bottle of peanut butter. And that's because in each case, it contains the same number of bottles of jam or number of bottles of peanut butter. So you can just count the number of cases. Instead of counting by 6s, we're just going to count by 1s. So there are 3 cases of jam and 2 cases of peanut butter. Use what you know about counting and patterns and what you know about the order of ratios to set up the ratios for each of these 2 problems. That's all we need to know about beginning ratios. Remember that in this introduction, we wanted to learn what are ratios. There are ways that we can compare 2 quantities. And we needed to know how to make the ratios. Well, we count 2 groups and compare the number between the 2. We put a colon in the middle or the word TO between the 2 quantities that we have. That's all we're learning in today's first lesson, Introduction to Ratios.